Hello, everyone. Welcome. Thank you very much for joining us today for our Meyer Spacemap Go webinar presented by TC Furlong, Inc. Before we dive right in, I want to do some brief introductions. My name is Posega. I'm on the TC Furlong, Inc. sales and marketing team. I'll be moderating today's discussion. Let me give you a brief introduction to TC Furlong, Inc., just in case you aren't familiar with our company. We're a live sound company based out of Chicago, out of the Chicagoland area. We have clients and do business not only here in Chicagoland, but across the Midwest and across the entire country. We operate with 4 main departments that work together to create solutions for our clients. Those departments are equipment sales, equipment rentals, live event production, and a whole host of services, which includes repairs, loudspeaker system design, loudspeaker system tuning, RF coordination, and a whole lot more. So if you'd like to learn more about our company, I'd encourage you to check out our website, tcfurlong.com. You can also follow us on all of the major social media platforms at TC Furlong Inc., and that includes YouTube. I want to let you know that we are recording today's webinar and it will be posted on our YouTube channel within the next day or two. So if you miss anything here today, or if you want to come back and review anything that you see here, keep an eye out for that and you'll be able to come back and take a look at that. Or especially if you think anything that you see here today could benefit someone who's not joining us here live, I would strongly encourage you to share that recording with them once it's available. With that, I want to introduce our guest for today. Joining us from Meyer Sound is Josh Dorn-Fehrmann. He is a technical support specialist with Meyer and an all-around expert on Spacemap Go. So Josh, thank you so much for giving us the time today. How are you doing?
Good. How are you?
Doing great.
We're here virtually.
We're here. Very happy that you could join us. Before I let you loose, just want to tell our participants today that we encourage any and all questions. Please type those questions into the Q&A box in Zoom. We can't really monitor the chat and make sure that we'll catch all the questions that way. But if you type them into the Q&A box, we'll be able to see them and make sure that we get to all the questions that we possibly can.
Yeah, for sure. Aaron is in charge of making sure that I answer all your questions. So yeah, please Absolutely. Just interrupt me whenever. Cool. So shall we get started?
Yeah, absolutely. Go right ahead.
Cool. Let me share my screen and let's go desktop. Let's handle the Zoom business first. Can everyone here see my screen?
Looks good to me.
Okay, great. Cool. Well, welcome everyone. As Aaron said, my name is Josh Fehrmann. I work for Meyer Sound in tech support and technical services. And I've been doing, I'm a theatrical, my background's in theater design, but I also was a touring sound engineer as well for live audio. And so I've got this weird jack of all trades, master of nothing type thing that I do for Meyer Sound. And I'm here to talk about Spacemap Go today. So the question, of course, is what is Spacemap Go? And so Spacemap Go is the brand new immersive mixing platform that we introduced in October of 2020. And since the pandemic's been going on, most people haven't been doing shows, and it's a great time to learn, but it's also not a great time to release a product. So we've been doing these virtual events to try and spread the good news about Spacemap Go. And we want to tell you about it because it's really exciting. So this is the immersive platform that we just released for the Galaxy Network platform. And in actuality, Spacemap, the technology behind this, has been around for over 30 years. And chances are, if you've ever seen a show in Las Vegas or some of the largest shows in the world, you've heard this technology. For years, we had Spacemap technology in our previous generations of digital products. Shows like the Beatles' Love or Ka from Cirque du Soleil utilize Spacemap to move sounds around. But now with the evolution of immersive audio, what we've started doing is recently in immersive sound systems, we've seen that now people are starting to implement these sounds out of a theatrical environment and into a live mixing, live audio environment. And so in October, we finally released Spacemap Go. And as we said, it runs on the Galaxy processor. So all you really need is a Galaxy. And if you have more than one Galaxy, you need an Avenue certified switch for AVB. And then what controls all of this is the Spacemap Go application. And that is an iPad app that is free to download from the Apple App Store. And it's a really slick and elegant way to control immersive audio. One of the problems with immersive audio, not really problems, it's more of a challenge. One of the challenges with immersive audio is now we are doing this object-based mixing. And the way you control these inputs and move the sounds around has to be done in an elegant and slick and smooth way, or you're not going to use it. And so a lot of times people don't focus on that. But since we've had the underlying technology of Spacemap, what we did focus on was the controller. And we've also added a lot more features than previous generations of Spacemap. So people always want to know why the iPad? Well, very simply, the iPad is just the controller and the Galaxy is the server. And what's cool about this is you can have multiple iPads connected to your system. We also are making a plugin that will be coming soon. And there's a lot of different control that you can use with third-party open sound control as well. And one of the things that people ask about all the time is how many channels? Well, you can have up to 32 inputs into a Spacemap Go system, and those inputs can be AVB, AES, or analog. So, and that AVB is Milan certified AVB. So things like the Avid console, Avid just released the MLN 192 card that connects directly into this system. And so you can have an AVB network and send 32 channels from your console directly into your Galaxies and do this. And it's also important to note that your Galaxies are still the loudspeaker processor that you've come to use for traditional loudspeaker processing. So not only can you now tune your PA and do all of the things that you've always done, but now you have an immersive mixer that's at your disposal. And we've tested up to 16 Galaxies working together as one giant immersive system with Spacemap Go. So that's a total of 256 outputs. So it's infinitely scalable. And it provides a lot of really useful tools for not only sound designers, but for live immersive environments. And very simply, what's happening with Spacemap Go and with most immersive processors is they use what's called amplitude-based panning. We have a very custom algorithm that was designed in live sound, in theatrical spaces, specifically for the challenges of a live show environment. Most of the other immersive platforms they're using algorithms that were designed in labs. Well, because we're a live sound company, we have that experience, and that's why we chose this approach for immersive audio mixing. Other companies have actually written white papers as to why this is the favored approach amongst immersive audio. And it is a professional product, so it works with open sound control, which means that you can connect your console, QLab, or any other third-party device that speaks OSC, and you can actually control Spacemap from there. In addition, it also works with tracking protocols like RTT, RPM. So if you have a black tracks in your show or a live mixing event, let's say your singer is walking across the stage, you can actually use it to control the singer. Oh, and the best part about Spacemap Go is it's a free update to your Galaxy. So there's no extra cost in hardware. If you already own a Galaxy, all you need to do is update your firmware and download the iPad app. So when you think about it, there's over about 4,000 Galaxies already in the world. Any one of those Galaxies can now become an immersive platform for mixing and doing live events and live mixing. And so you can use Spacemap Go for a ton of things. And with the pandemic, necessity has become a level of ingenuity that we've had to evolve, and people are coming up with really cool ideas of how to use this new free tool. And it's really exciting. In addition, there's a whole bunch of benefits and advantages to Spacemap Go. And one of the most important ones is it works with any loudspeaker layout. So you can use Spacemap Go with stereo speakers. You can also use it with, 256 speakers. So it's infinitely scalable, and it still allows you to do some really interesting things. And we'll talk about that more in a bit. There's some more advantages. This is all marketing slides, but really what we want to talk about is how do we get connected? And I could show you how to get connected right here. So this is in real time how you get connected. The first thing you do is download Compass from our website. And then what you do is open up Compass. And if you're working offline, all you would do is add a couple processors. But if you're connected to hardware, you could just connect to the hardware here. In this case, I'm working offline. You can work 100% offline. Then all you do is go into Settings, Network, and then reboot all of the galaxies into Spacemap mode. So in this case, we're offline, so we're not using hardware, we're just working from our computer. And now you'll notice in Compass that the galaxies have changed color. And then on the Spacemap Go application, what you'll see is that they appear, and you get asked a couple questions. The first question is, what inputs do you want to use? I know I have 2 galaxies, so what inputs do you want to use, AES or analog? And you can choose how many you want to use depending on what type of galaxy you have. And then in addition, you can also have Milan ABB inputs as well. So since Spacemap Go and a galaxy has 32 matrix rows, you can have up to 32 channels over Milan ABB. Or if you have 4 galaxies that are analog, you can have 32 analog channels, because each galaxy has either 8 or 4 analog or AES inputs. And then very simply, you open up the app and load a Spacemap in, and you can be up and running within 5 minutes. And we'll actually do that right now. And I'm going to stop this keynote. 1 second. And let's go into the galaxy. Can everyone still see my screen?
Yep.
Okay, cool. So here we go. What we have here is 2 galaxies, 3 galaxies. I have 2 galaxies that are called TC demo. And if you want multiple galaxies to work together, you just assign the same group name. And they're in normal mode right now. So this would perform like a traditional PA sound system tuning. If I want to put them into Spacemap mode, I simply click into the inventory, I go to Settings, and then I click Reboot to Spacemap mode. So we're going to reboot actually just these 2 devices because I already have another system in Spacemap mode. And while that reboots, it's going to power cycle the galaxy and then turn it orange. And you still will have access to all of your tunings that you need to do for loudspeaker processing, but it'll turn orange and look something like this. And we're going to do a quick little frontal system for Spacemap. And so I'm going to just type in some output names here. Let's see, frontal left, frontal left, frontal center, frontal right. And let's say we have a sub and a surround left and a surround right. So right now, this is a Galaxy 408 system. And I've got, let's say I have a five speakers that I want to use for a 5 frontal system. Those are all the rage right now. Then we have a subwoofer and then 2 surrounds. I can now, once I've configured my system, go into Spacemap Go, and very simply, I can see that my outputs are here. And then what we'll do is create a space map for our frontal system. So very simply, I can insert some loudspeaker nodes. And we'll talk about what this is, but I just want to show you how quick it is to get up and running with a frontal system. And then I'm going to add a derived node. We'll talk about that, but this is a subwoofer. And I'm going to link my subwoofer to all 5 of my frontal speakers. And then very simply, I'm going to add some virtual nodes. And a virtual node is, we'll talk about what that is. But what we're going to do is quickly build a panner for our 5 frontal system. And I'm going to use my finger to set the rest of this up really quickly. 1, 2, 3, 4, 5. And then I'm going to add a couple more speakers, virtual notes. So I'm going to just add 2 in the back right here. And we'll put snap to grid on, make our lives a little bit easier. And again, we're doing this live in real time to show you how easy it is to control a frontal system with Spacemap Go. I'm just making this a little bit pretty. And we'll link, let's see. I want to link this guy. Oops, there we go. I'm going to link this one to these 3 speakers, this one to these 3, and this one to these 3. And very simply, I'm going to add some trisets, and I'll explain about what all of this is. Here we built some trisets. Trisets are your panning surface. And now we've built a frontal system for 5 loudspeakers. And what we can see is we'll just load that space map that we just created. We'll load that onto our first 8 channels. 1, 2, 3, 4, 5, 6, 7, 8. And now we have a frontal mixer. Let me add a couple trajectories just to show you that it's moving around and move some channels around. And if we go to our overview, we can see that we have all 8 channels, and we can show a space map. And so we can see we have 8 channels now moving around in the space. And so now, very simply, in under, I hope, 3 minutes, we have a frontal mixer. So we can do a frontal immersive environment. So did that bring any questions? I know people might have questions.
No questions yet.
Okay.
Everybody feel free to submit those questions in the Q&A box. One thing I do think bears repeating and reinforcement is for anyone who's not familiar with the Meyer product line, as you mentioned, Galaxy is the default system processor right now. And maybe you can elaborate on that a little bit more.
Yeah, absolutely. So here we would have a loudspeaker processor. So let's say my frontal PA, I'm using an X40. Well, I can still use and do all of the loudspeaker processing, and EQ and delay and parametrics, all of the things that is included in here. I could still tune my PA. And now with this free update, all I do is put my Galaxy into Spacemap mode. And I'm just using Spacemap Go to control the matrix level using the Spacemap Go algorithm, which is a custom algorithm that we've had around for about 30 years that makes immersive audio and panning very, very easily and very flexible.
And another kind of establishing question here that I think is worth getting into is you do not need to have a traditional surround system set up in your venue. Is that correct?
Right, absolutely. Now there is the laws of physics still apply. So if I was to do a frontal system like we just did here, the physical spacing of the loudspeakers within the room has to rely on the fundamentals of system design. So it's all about picking the right speaker for the room, putting it in the right place, and pointing it in the right direction. With immersive audio, the rules of proper system design change because we've spent decades making mixed mono or stereo systems to where one speaker has control of a certain section of audience and another speaker has the control of the other, and they meet up right at that 6 dB down point to provide uniform coverage. With immersive audio, the sort of rules change, and it's all about overlapping coverage. And what's unique about immersive audio is the correlation and decorrelation of signals actually happens within the processor and within the algorithms that all of these immersive systems are using. Our algorithm is unique in that it's a very customizable process. And that gets into a question about what a space map is. So yeah, we have questions, or should we keep going?
Let's see, we did get one question that might be something we'll go over a little bit later, but I'll pose it to you now, which is asking if you can go over linking derived nodes. So maybe that's something
Oh
we can.
yeah, yeah, we'll definitely go over that real quick. But yeah, let's say, for example, here, I'm going to just do this in real time. That's one of the cool things about this compared to another workshop is, let's say, for example, I have 4 speakers and a quad setup. Ignore the names, but let's say we just have 4 speakers. And let's say I have a subwoofer, and my subwoofer was on Galaxy output 5. Very simply, if I want the sound to send to the subwoofer, I click link, and then I just link the speakers together. And let me build some trisets. And we'll go in next, we'll talk about what a space map is. And here we have some trisets. And now we can see that as we pan around, our matrix levels adjusting. We also see that output 5, which is currently labeled frontal because I didn't label it properly, but we can see that that output's getting fed. And so this allows you to do absolute values for subsystems. And I have a whole bunch of examples we can go into. So yeah, let's go back into the keynote and talk some more about what a space map is and what is this weird thing that Meyer Sound's released. And it's not weird, it's actually really, really cool, in my humble opinion. So adding abstraction to object-based mixing is really what we say space maps do. And so what do we mean by that? Well, if we look at immersive audio and how it's developed, it really comes back to a stereo world. And here's what we've always done. We've had a whole bunch of inputs. They've always fed a console. And out of that console, we've sent all of that information down 2 different pipes, whether it's a mono or stereo system. And so the console has been very good at doing things that we need to sculpt audio space of that limited frequency spectrum that we have. EQ, dynamics, effects, reverb. And so here, immersive audio has started coming along recently, not only in theatrical environments, but in live sound. And now we have a little bit of a different approach. And the first thing that happens is you'll notice that coming out of the console, it's now the instruments are split and sent down to the immersive processor as individual instruments. And in that term, it's called objects. And so those individual instruments or objects send to the immersive processor. And the immersive processor does very good things. It handles the movement and the spatialization of things. And so with traditional immersive processing, which I'm not even sure traditional is an appropriate word for it, but with immersive audio and most of the algorithms that other companies are using, the problem is that the loudspeaker locations have to have a very fixed and specific location in order for the sound and the feeling of immersion to work. And while that may be true for us, in some instances of different formats, like if I want to have 5 across the front, of course, physics dictates where you would need to place that. And we go into that extensively on the Spacemap Go help website. Bob McCarthy has actually written a sort of guideline for immersive sound system design. But because those algorithms require a whole bunch of speakers and have very fixed positions, it's not conducive to a live mixing environment and a live sound environment. We, as live sound practitioners, sometimes just have 2 speakers. Sometimes the production manager says we can have 4 speakers. What's cool about this format is we can use Spacemap with any loudspeaker setup that you have. Now, how much immersion you have, of course, depends on the laws of physics. But if I have 4 speakers on sticks and I want someone to feel a movement, I could easily do this with the processor. We could also use it for a frontal system, which is all of the rage right now. And then the question becomes, how do we control all of these new objects? And so companies have come up with these controllers, and they all look very similar to this. And they're called object panners. And so sometimes there'll be a circle, sometimes there'll be a square, sometimes there'll be a 3D panner. The Atmos panner, for example, is a great example of a 3D object-based panner. And this is great because this now allows us as engineers to have objects and very quickly move sound around. And now with frontal sound systems, we have a different type of panner, which is usually like a half semicircle to where it's from the stage perspective. And here we go. So now we have an object-based panner, and my objects, the thing about all of these is if I move my sound to the top left corner, regardless of the loudspeaker layout, my objects will always sound like they're coming out of the top left side of the sound system. And if I move all of my objects to the right-hand side, the objects will also sound like they're coming out of the right-hand side of the system, regardless of size. And what these immersive processors are doing is they're allowing you to control the algorithm. They're using the algorithm to make this distribution of audio very easy and simple. And generally at the end, you're presented with something like this, which is you have one controller and you have all of these different objects. Well, you can do that in Spacemap with the overview window like I just showed, but Spacemap Go also allows you to have individual control over every channel. And what's unique about a Spacemap Go compared to these others is we let you design the panner that you need for whatever you want. So yes, a Spacemap is a custom panner. And so every channel on here has the same Spacemap, and that will make it behave the exact same way. So you can move objects around and place them. But what's cool about Spacemap Go is you can also have 32, each channel can have a completely different panner on it. And you can create the panner that you need for whatever sound you have. In addition, you can also have 2 space maps on each channel. Why would I ever do that? Well, a space map is a custom loudspeaker configuration. So it's a representation of a loudspeaker configuration. So theatrical designers use this to have an overhead space map that just has overhead speakers. And then they also have a space map that has a lateral speaker system in it. And what they can do is crossfade a sound from up above and down below. Lots of things you can do.
So Josh, if you don't mind me jumping in there, one of the questions we did get is, it looks like so far we're looking at this from sort of a plan view or an overhead view. And this question was asking about, getting a vertical slice view. And it sounds like what you're talking about is with the 2 space maps in conjunction, you can kind of move in both planes.
Well, it really, it depends on how you want to draw it. And we'll show some examples, but one example is you can have just draw in your lateral speaker outputs and then have one space map with that. And then you can have another space map with just your overhead speakers, or you can draw your lateral speakers on the outside of the space map and then draw your overhead speakers on the inside, and then use the one space map to do an up and over sound. And we have examples of that. We'll get into it.
Great. And another question we got that I think leans more into the sort of system design aspect you were talking about was, how does this work with obstacles or multiple levels of seating like balconies?
We'll talk about that. We'll get there. I have some examples to show.
Great.
So, and so that leads us, that's a great segue into what the heck is a space map? And so let's talk about it. So as we've said, a space map is a visual representation of a loudspeaker layout. The difference between us and everyone else is we allow you to manipulate that loudspeaker layout and create the custom panner that you need for the show, or for the obstacles in your room, like architecture, which most of these theaters have problematic architecture. And so a space map is an abstraction of a loudspeaker layout. And what we mean by that is the panner doesn't have to look like the room. And so let's just talk about how a space map can be made. Space maps are composed of 2 different objects. The first type is a node, and a node, there's different types of nodes. So here on the right, we have an example space map. And the first type of node is called a speaker node, and that's very simple. It represents an output on a galaxy. Here we can see that we have 4 speaker nodes. And then the next type of node is called a virtual node. And a virtual node is a multi-purpose node, and it allows you to connect trisets, which are triangular planar surfaces. We won't talk about that, but it also allows you to send audio to multiple sets of loudspeakers, and it uses what's called weighted distribution of audio to loudspeakers. And we'll do some examples. Excuse me, my dog has decided to want to come in. 1 second.
The more the merrier.
Yes, I had him locked up, but I guess my wife decided he wanted to come out. So the next type of node is called a silent node, and a silent node reduces the level of an object. So as I move my panner towards the silent node, I can actually reduce its level. Let's say I have a drum kit and I wanted to get it quieter. I can move it towards the silent node and the drum kit will reduce in level. Theatrical designers use this all of the time to create fade ins and fade outs of a sound. And then the last type of node is called a derived node. And this is basically the aux send, or it's equivalent to an aux send on a console. And what you can do with derived nodes is this is how you can deal with subsystems. So a derived node allows you to receive absolute audio level from any speaker nodes that are linked to it. So in this example, we have 4 loudspeakers linked to the subwoofer, and that allows us to base manage these 4 speakers so that they get low frequency energy. And we have some more examples of using this for fills and front fills and side fills and any type of fill. But last but not least, and this is where the magic of Spacemap is happening, it's in the triset. And a triset is a triangular panning surface. And the Spacemap Go algorithm allows for equal power panning amongst a triset. And the best way to explain a triset is to think about a pan pot on a console. And that's a 3-point move. If I go 100% left, that's 1 point. If I go 50% left and right in the center of the pan, that's another point. And if I go 100% right, that's a 3rd point. So that's 3 points, triangle. There you go. That's a triset. And so trisets can be linked to different types of nodes: silent nodes, virtual nodes, and speaker nodes. And we won't get into detail on this. There's a lot of information on it. But the way to think about this is when building a space map, I think of it like building a tent. The nodes are your stakes and poles that you need to build a tent. And the canvas that goes over your tent is the triset. So without trisets, you don't have sound. Without the canvas, you don't have a tent. So you need to build trisets in order for the audio to move around evenly. And we actually have a tool that allows you to do this automatically. So here would be a space map for a 5.1 system. And this would look like a normal object-based panner. And here, as we saw before, here would be a space map for a frontal system. And as we moved our objects along, it would track with the loudspeaker layout. And so here's some of the difference between normal object-based mixing and Spacemap Go is you can use this with any loudspeaker layout. You can still do the traditional object-based panning, but you can create a custom panner that you need. And then you can have up to 64 different panners at once. So you can have completely different control of your sound system. And the difference between us that is fundamental is the Spacemap algorithm was literally created in a theater. And it's been in the market for 25 years. And so we have 25 years of experience of how this should work in live sound environments. And let's do some examples, and then the rest of the time we'll open up to questions. So let's say we have a room full of speakers, and this is our room. We have a 5 frontal system, 3 surrounds on the left and right, and two rear surrounds. So here would be one space map. And this space map is a very granular space map. So as I move my finger around, we'll notice a white halo that expands and contracts. And that's representing the matrix level of that particular input that it's on. And so this is a visual way for you to see where the sound is. And also it is great for pre-programming offline because it tells you where your sound will be. Here's an example of a frontal space map. As we saw, we created it in 3 minutes. Here's that same type of space map. And we can see that as we move up the y-axis or up and down, we can see that the sound is sort of spreading out. And so this is how we can add width to a sound with a space map. So up at the top of the space map, we have very wide sounds, and down at the bottom, we'll have it focused on very specific positions. And you can design all of these very quickly. But sometimes you might have more loudspeakers and you might want a little bit different control. What if I wanted to divide the room up into 4? Well, here's a space map that does that. If we go along the edges of our space map, we can still have the granular control that people are used to. But now, using virtual nodes that we link to multiple speaker nodes, we can send a sound with weighted power so that we don't have summing or uncorrelation. We can send a sound to multiple speakers. And in fact, in the center, we linked all of our surround speakers. So if I have a quad reverb, for example, I could put each one of those reverb channels in one corner at one of these virtual nodes, and then I would have a quad reverb for my room, very simply. Or let's say we wanted to divide the room up in half. I use this a lot for reverb returns and for all sorts of other interesting fun things. And so here's what we call a half and half space map. You just build it yourself and link the virtual nodes however you want. And what's cool about this space map is you can divide the room in half left and right, but you can also do north and south. And so here we have a space map. We have granular control still on the outside, so we can move a sound around if we need to. But we can also move it left, and then we can move it right, and control half of the loudspeakers in the room. So we can literally send a sound to half of the room, and you don't have to worry about the summing, because the algorithm is provided, virtual nodes are provided weighted power distribution. So if I have 85 dB coming in from my console, that 85 dB is mathematically distributed to whatever speakers are linked to the virtual node. So that allows for equal power panning, so you don't have to worry about summing and all of the loud things that you do. Okay, so we showed a frontal system, we showed a surround system. That's cool, but what if I want the best of both worlds? What if I want a panner that allows me to do the cool frontal mixing that's hot right now and still control some of the surrounds? Well, this panner would not cut it. This space map wouldn't cut it. And so what I could do is just move my speaker nodes down. And now I have a frontal panner up top and then a surround panner in the rear. And because I thought the quads were cool, I just added a couple virtual nodes and I can still control my quads. And if I want to reach all the surround speakers, I just go to the virtual node in the center. And here we go. So the top half of this space map is a frontal panner. Very simple, allows us to do all the cool things that all the cool kids in the industry are doing right now. But also, because space maps are an abstraction of a loudspeaker layout, we can now have a panner that allows us to do the quad, sending quad information to multiple loudspeakers in the room. And we could do a demo now, but I want to get to this for derived nodes. So here's another thing that space maps are really good at, which is down mixing. So in our room, let's say we had 5 frontals and 4 surround speakers. And let's say our mix console or our booth for broadcast was 5.1. Well, here is a space map that's linking derived nodes to the booth monitors. That way, in my live room, as I move a sound around, we can still do a 5.1 mix down for whatever loudspeaker layout we need. And it translates. So whatever I'm doing in the room goes down to broadcast very simply. And of course, you could take that one step further let's say I have a 5-1 and a 7-1, or a 5-1, or I need to control 2 rooms or 3 rooms at once. In this space map, we have a loudspeaker layout on the outside in the room that we're in. And then we have 2 other loudspeaker layouts that are using derived nodes. And so this space map would actually be controlling 3 rooms worth of loudspeakers, very simply. And it all translates. So whatever I do in the room I'm in translates to the other 2 rooms that are made from derived nodes. And it goes beyond that. We also can do monitor mixing. So let's say your monitor engineer has an act that is very dynamic. All you need to do is plug in a galaxy out of your console and plug in your monitor wedges into the galaxy. And very simply, your monitor mix now becomes, can be handled automatically. Let's say the actor or the singer is on trackers. Now you can track where their mix is coming from automatically as you move them around. So I know that's a lot, and I'm sure there's questions. So let me end the keynote and just get into the app, and I'm happy to answer any questions.
Yeah, so that is a lot to think about. Definitely a different way of thinking about mixing. A couple questions we got were about just the patching and the Galaxy platform specifically. First is talking about the individual panners per each source or each object. Each of those objects would be associated with one input on one galaxy, correct?
Correct. So in this example, well, here, let's just configure a real system. So we have 2 galaxies that we put in a space map mode earlier in the demo. So what I'm going to do is, here we go. Yeah, what I'm going to do is just go up here, and we can see that those galaxies are right here. And what I can decide when you're configuring the system is what galaxies you want to use for inputs. And so TC1, my first galaxy, it's like stacking galaxies on top of each other. So those first 8 analog inputs on top are the first 8 channels of the Spacemap Go system. And the 8 channels from TC demo 2, those would be channels 9 through 16. So, so here we go. I click proceed, and now we're saying the system's telling us we'll have 16 physical inputs. And since it also has Milan, you can have up to 32 AVB inputs. But in total, you can have up to 32 inputs. But in this case, I just want to have 16 analog. Let's make it super simple. So now I click Save to System, and the system will do all of the work for you. And it configures it for you. So here we go. I have 16 galaxies, and it's going through its configuration process. It's ready. And if we go into the settings window, we can see that we have our TC demo 1, TC demo 2. We look at compass, we have TC demo 1 and TC demo 2. And what makes this work is the Milan switch and Milan AVB. What happens when you have multiple galaxies and they're connected to a Milan switch is that configuration process interconnects all of the inputs from the galaxy that you decide to every other galaxy on the system. And so if we look at our settings window within Spacemap Go, we can see the first galaxy as analog. But if we go to our next matrix row, actually, I think it's here. Yeah, on our next matrix row, we can see that our inputs are here from the second galaxy. And so what happens is it creates this giant interweb, interlocking cross-point matrix of all the galaxies. And the system does that for you over Milan. And since you can have full redundancy with a complete Milan setup, so you can have 2 switches, 2 different Ethernet ports, and it'll do that for you up to 16 galaxies is what we've tested. Does that answer that?
Yeah, I think so. And a related question, does using the galaxies in Spacemap mode add any latency?
No, not at all. No, it's still the same latency. Yeah, still the same galaxy latency. The only latency that you will get is if you have multiple galaxies. Because it's using AVB, you'll have the presentation time. Let's see. Yeah, we'll see here. What part of the Milan AVB paradigm is that you have a presentation time, which is the longest travel path that an audio packet will have to travel. And the network dictates that. In this case, it's 2 milliseconds is what it's fixed at. And let me look at it. And in reality, it's 0.367 milliseconds. That's how much latency we got added. So 0.36 milliseconds. I hope that's okay. And while it was connecting, it flagged some errors, but it's all locked up and fine now. So there we go. Yeah, 0.367 milliseconds of network latency.
Great. Another quick galaxy question. If you're using 16 physical inputs over 2 galaxies, do you still need them to be networked via Milan, even if you're not sending Milan anywhere else in the system?
Yep, absolutely. If you have more than one galaxy, you need a Milan switch and Avenue certified switch, not a, so yeah, Avenue certified switch. So there's a couple out there. Luminex makes one, a whole bunch, Extreme, I believe Cisco might have one now. And so, yeah, what we, that's what you need. And it's completely scalable. The other thing is you can send this AVB broadcasting out of these outputs to another Avenue or Milan certified device. So a lot of times people will keep galaxies in spacemap mode in front of house. And then if you have a line array or something, you keep those running in normal mode and just link the AVB from the spacemap galaxy to the normal mode galaxy that's handling your line array. So that's how you handle line arrays as well. So in Spacemap, it's just one output is sending over AVB to the next galaxy, which is handling the line array.
Great.
Oh, and one more thing, Aaron, let's just talk about where this is happening. So we have 2 galaxies. So I'm going to just load one of our space maps. Let's just put this one on. We have a pre-included library. And what we can see is, as I move around input 1, we can see the summing matrix on the first galaxy change. And then let's go over to channel 9, for example, which that would be here on this galaxy, input 9. I could load a space map on this channel, maybe a different one. And actually that channel is arriving where? Here we go. I don't know why what's going on. Anyway, my dog's trying to get into the Zoom meeting. So yeah, there we go. There it is. So there we are. And yeah.
Great. And we had a question that came up earlier in the chat referring specifically to the map that you put together right at the beginning of the presentation, just to show how easy it was, which was, does that map cover only the stage? Does it cover the audience? In theory, what's the application of something like that?
I mean, yeah, that would be a frontal system. So if you had, let's go back to the slide. Where did I have it? Okay, here we go. Yeah, so here would be that same space map that I made. And here would be those 5 loudspeakers. These are line arrays, but these could very easily be, something like an X40. That would be there. And then we just have a subwoofer behind it that would link to all of these 5 speakers. And that would do all the bass management for you. And if you loaded that space map onto your channel, you can pan sound around.
Great. And then let's see, question from Doug here. Asking, 32 total inputs doesn't seem like a lot for a music show, like a live concert, for example. So maybe if you could elaborate a little bit more on how someone might use
Yeah.
those 32 inputs.
Yeah. So Spacemap Go is input agnostic. So chances are in a live mixing environment, you're going to still have a console, right? And this is a big debate right now in the immersive audio world. Not debate, but it's a discussion as this technology starts evolving, which is how do we decide what to send into the immersive processor? And there's a couple ways to do it. One way that people have been sort of thinking about is sort of doing a 5.1 static mix from their console. So in that case, we would have something that like a 5.1 space map. Let me see if I can find one. Let me sort by ID. We have a pre-existing library of tons of examples that you can go from. And if you sort by ID, that it starts from simple to very complex space maps. But here would be a space map of a 5.1 system. So let's say those 5 or 6 outputs were here. And actually, let me just recall this. We have a 5.1 setup for you. So if you just recall the 5.1 snapshot, here would be a 5.1 setup. So out of my mix console, I plug into input 1, 2, 3, 4, 5, and 6 in traditional 5.1 into my first 6 inputs in my Galaxy. And then I wouldn't touch this. In fact, I would probably lock them out. So let's say my first 6 channels here, now I can't control them with the iPad. So whatever I send from the mix console, I just lock out. And then now that gives me, in this case, 7 more, or I can't do math, but 16, the rest of the channels for moving sound effects or instruments around. One other thing you can do is link channels. So let's say you have a keyboard or a drum. You can link them in different ways. In this case, I linked channel 9 and 10 together. And so now I mirrored them on the x-axis. So if we have a stereo system, we could simply just control our left-right of our keyboard in our space map however we want. And we can change that behavior. Let's say we have a stereo feed and we want to mix it down to mono. Now it's linked to mono. Let's say we want to get funky and do mirror Y. Oh, my reflector app close. 1 second. I'm using a third-party app from my that turns your computer into an Apple TV, and sometimes it misbehaves, especially when you're trying to do things. So here we go. All right, back to it. So now we've linked our channels on the y-axis, but not the x-axis. Or if we want to have both links, we could do mix XY and get really crazy with it. And so you can add a trajectory. One thing we didn't talk about is trajectories. And trajectories are just pathways for your sound to travel through. So I just loaded a line trajectory. And since these channels are linked in this way, we can see that the sound is moving around right here. And because we're on an iPad, we've made it elegant to where you could touch this trajectory button. And in real time, I'm going to just speed this audio up a little bit so you can see what's going on. In real time, while the audio is going on, I can move this trajectory around. I can also pinch with the iPad, and I can expand and contract using traditional iPad, gestures. And that's very cool. And to create trajectories, you just go up to here and you click new trajectory. You start recording. So in this case, let's say I have a sound that I want to come here, 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 and here. And let's say I want it to spin around the room. So I'm going to just hold down with my finger. And then I'm going to just hold it down and do something like that. Let's say I don't like that. I'm going to turn off my grid and turn off snapping. I'm going to re-record it. And now let's say I want my name to be the pathway that the audio travels. So there we go. Now the audio will be traveling. And in real time, while that audio is going along, I could just load the trajectory I just made. And now we're moving around the space. You can also import and export trajectories. So my wife made a trajectory the other day. It's actually on the other system, so I'll just connect to that. So here's my trajectory my wife made. It's called Sound to Source Rex. So let's say we had a space map here. I'll speed it up a little bit. And I'm going to use the iPad and just pinch and drag. And in real time, we're controlling the pathway and walking the dinosaur across the room. Or let's say I want to go from a 5-dot frontal system to a full surround system. Very simply, all I do is just crossfade that frontal system into my surrounds. And now I'm in the surrounds. And then I could just simply go back to the frontal or go back into the surrounds. And then, yeah, so that's that. I have some new features I can talk about.
Yeah, we're coming up on the hour here. So if you want to shout out those new features that are going to be coming, and then we can wrap things up.
So yeah, one new feature that will be coming very shortly with the next update is this first one, which is tap tempo trajectory. So let's say we have a pathway and we want to, let's say it's the circle. So we'll put the circle on. Let's say our song that we want to have has a particular BPM. Well, simply we can just tap in that BPM, 140. And now it's going to move along the tempo at 140. We can also decide how many beats per trajectory, so how many times it turns around. But we also have tap tempo now, so I'll be able to just tap in real time while mix is going on, and adjust the tempo. And again, since it's on an iPad, we can pinch it, we can make it smaller. We could swipe over, speed it up. We could change its direction. And so there you go. That's a cool new feature. The other new feature, a couple new features, is AVB connection will be super simple. So for example, I have my Mac connected to my Milan network. And so if I click up here, edit AVB connections, we can see that my other galaxies have appeared on the network, but we can also see that my Mac has appeared. And I can just simply drag it in. So if this was the Milan console, it now will ask you about rippling channels. And so if I had my Milan console, instantly it linked all 32 channels to my galaxy. I click done, and it's going to go through an auto configuration process. There it is. And now I have 32 Milan AVB channels connected to my system. So there you go. There's a couple more that are coming, but one thing I do want to talk about, and let me just go to the other system. Oh, wrong system. Let me unlock this. One thing I do want to talk about is snapshotting. So you can have a snapshot. Let's say I want to load this space map on all these channels. And let's say the first part of my show, I want to start these 4 channels or these 8 channels at the top left corner of the room. I can do that. And what I'll do is create a new mix snapshot. And we go into detail in this, but it's just really fun to see. So a mix snapshot takes a picture of all 32 channels. And then within mix snapshots, you can have channel snapshots. And so that's what I'll capture here. I'm going to just capture these first channels. I'll say top corner. And we'll add a transition and a wait time of 3 seconds, transition time of 8 seconds. And there it captured that. Let's go back here and put some of these channels on trajectories. Oh yeah, there we go. I copied the wrong ones, but it's all good. So let's say we have these trajectories on and put it on these. Oh, yeah. I'm doing this live, so 1 second. So this is another new feature, is you can put a space map on multiple channels at once, or you can use the overview. And now you can enable touching of the overview. So while I have sounds moving around on trajectories, I can also take individual elements and mix them around. If I want to group channels, let's say this channel, and this channel, I want to be grouped together and work. I can just put them into the corner, and now all three of those channels will be controlled by one finger touch. So this allows you to group channels on the overview window only. And if I wanted to change them, I would have to go back into my my channel layout and just adjust things. So yeah, there's a lot, and we can talk for days about it.
Yeah, absolutely. There's a lot that we could cover and that people can learn about. So, Josh, I know there were a couple resources that you wanted to shout out for people before we sign off.
Yeah, let's see. In the chat, I think have we posted links yet or no?
Yeah, I believe we have.
Okay. So the first resource is let me share my screen, desktop. There we go. The first resource is the Spacemap Go help website. If you're in the application, it's right here. Yeah, right here. Spacemap Go help. You can also Google Spacemap Go help and it'll pop up. And that's really the operating instructions, but there's tons of useful information on there. Everything from recommendations on system design. There's a template QLab file with every single OSC command. Our OSC library is published. There's just a ton of really useful information on details of how to get this set up and going. Yeah. Oh, and then what else do we want to mention? Remind me, Aaron.
You had mentioned the Meyer Sound Facebook users group.
Oh, yeah. One thing that people kind of aren't aware of is we have a Meyer Sound users community on Facebook. And yeah, we just posted the link into the chat. Feel free to join. It's a great community. We want to see what you're doing and cool stuff. So if you ever are working with our products and are doing something cool with it, feel free to add it there. And it's just a cool community. We also have the Spacemap Roundtables on YouTube. So we have about 6 hours worth of training. The first 3 hours are on how to use the application. The next 3 hours are with Bob McCarthy and myself, and we talk about system design for immersive audio. And we show you Bob's design guidelines for Spacemap Go. And then, of course, we have the AES Spring Training in Nashville, Tennessee event coming up. So we will be having Pooch. Pooch is a Van Druten. He's a mixer for a long time with artists like Linkin Park, Justin Bieber, Iron Maiden. And we'll also have Denny Miller. He's a mixer for Volbeat and Miguel. And they will be at the AES event, which is a spring training event. It's free at Soundcheck in Nashville on March 31st. And what's cool about it is we'll have a room, L Acoustics will have a room, D&B will have a room, and it's going to just be a day of immersive training. And signups are at that link below. And so if you want to hear the systems, we have a couple demo spaces. We have one in Nashville, we have one in the New York, and then New York City, and we have one in Burbank as well. But also if you talk to TC Furlong and talk to your local sales manager, they can connect you with and maybe perhaps a local dealer that's also doing Spacemap demos.
Awesome. Well, with that, I think we're going to wrap things up. So Josh, thanks again for giving us your time today and sharing your knowledge with us. Great to learn about this really cool new product.
Yeah, it's free. It's a free update. So if you have
free
a
new
Galaxy,
product.
just update. Yeah, that's a value add. And also, if you look at the price of a Galaxy, and think about what it can do, not only in loudspeaker processing, but in immersive audio now. It actually gets you into the door of this pro audio, immersive audio very, very quickly and relatively inexpensively.
Absolutely. Thanks again, Josh.
Cool. Thanks, everyone. Cheers.
And before I let everyone go, just want to let you know, please submit any additional questions you have to us at sales@tcfurlong.com. There is also an exit survey that we encourage you to take if you have any suggestions or requests for future webinars. And speaking of future webinars, our next one is coming up on Tuesday, March 30th, again featuring Meyer Sound. And this time we're going to be learning about Map 3D. Which is Meyer's sound system design and prediction tool, now, as the name suggests, in 3D. So that's coming up on March 30th at 3 p.m. Central. I believe we're dropping a sign-up link in the chat. We will also be sure to follow up with an email to everyone with that information as well. So thanks again to Josh. Thanks to my colleague, Matt Calera, helping us out in the background here. And of course, thank you very much to all of you for joining us here today. I hope everyone has a great day, and I hope to see you again next time.
Bye, everyone. Thank you.